Hello viewers, welcome to UN Digital class. In my previous lecture, I have already discussed about the first order logic. Now, in today's lecture, I am going to discuss about inference in first order logic. Let us start. Inference in first order logic is nothing but it is used to derive new facts or new sentence from the old sentence. That is called the inference in first order logic. Next, inference rules. In inference rules, first of all I would like to discuss about universal instantiation, that is UI. Here this universal instantiation says that we can infer any sentence obtained by substitution a ground term for variables. Before understanding this definition, first of all we have to know about what is ground term and what is substitution. Here ground term is nothing but it is a term without variable, that is called the ground term. Next, substitution. Let substitute A comma B denote the substituting A to the sentence B, that is the substitution. Now in universal instantiation we use this ground term and substitution for instantiating our sentence. That means in universal instantiation we substitute a ground term for a variable, that is called the universal instantiation. Now look at the rule of universal instantiation. In this rule, that is for all V alpha, substitute V by G alpha. Now look at this rule. In this rule, V is nothing but that is the variable and alpha is the sentence. Now look at the substitution. In substitution, V by G means here V is the variable which is substituted by our ground term, that is G, in the sentence alpha. This is the rule of universal instantiation. Now look at the example. In this example, for all x, king x and greedy x implies evil x. That means here x is a variable and this sentence is represented by using the x variable. Now from this sentence we can infer new sentence or we can derive new sentence by replacing the variable x by some ground term. Now look at the derivation of new sentence. Here King John and greedy John implies evil John, which means in this sentence x variable is replaced by the ground term. That ground term is nothing but that is the John. Then look at the next sentence, that is King Richard and greedy Richard implies evil Richard. In this sentence the variable x is replaced by the ground term, that is Richard. Now look at the last sentence, that is King father of John and greedy father of John implies evil father of John. Now in this sentence the variable x is replaced by or substituted by the ground term, that is father of John. In this way we can use any ground term in place of our variable x and derive the new sentence. That means in universal instantiation here the important thing is that we always use a ground term for substituting the variable. After substituting the variable by the ground term, then we infer a new sentence. That is the main aim of universal instantiation. Next one is the existential instantiation. Now look at this instantiation. Here the variable is replaced by a single new constant symbol. That means in existential instantiation here the variable is substituted or replaced by a constant value and that constant does not appear in any knowledge base. Now look at the rule of existential instantiation. In this rule there exists V alpha, then substitute V by K alpha. Here V is the variable alpha is the sentence and k is the constant. That means in alpha sentence we substitute the variable v by the constant k. That is called our existential instantiation. Now look at the example. In this example, there exists x, crown x and on head x John. Here x is the variable and this variable is nothing but it is the existential quantifier variable. Now we use the existential instantiation. That means here we replace this variable x by a constant. Now look at the new sentence, that is crown C1 and on head C1 John. In this sentence C1 is the constant which replace the variable that is x, and this constant is only available for this knowledge base. That means here the constant C1 is not used any other knowledge base. This is the existential instantiation. Now look at the difference between UI and EI. Here UI is the universal instantiation and EI is the existential instantiation. UI can be applied several times to add new sentence. That means the universal instantiation can be applied more than one times to add new sentence to our knowledge base. And the knowledge base is logically equivalent to the old one. That means the new knowledge base is logically equivalent to our old knowledge base. Next, existential instantiation, that is EI, can be applied once to replace the existential sentence. That means in our knowledge base, when we use the existential instantiation, then that existential instantiation can be applied only once to remove the existential sentence. Then the new knowledge base is not equivalent to the old knowledge base. That means here the main difference is that universal instantiation is used more than one times to add the new sentence to our knowledge base. But the existential instantiation can be used only once. And in existential instantiation, the knowledge base, that means the new knowledge base, is not equivalent to our old knowledge base. But universal instantiation, the new knowledge base is equivalent to the old knowledge base. These are the main difference between universal instantiation and existential instantiation. Next, reduction to propositional inference. Suppose the knowledge base had the following sentence. These are: for all x, king x and greedy x implies evil x. Then next one is King John, greedy John. Then next, brother Richard John. That means here these are the sentences which are already available in our knowledge base. Now from these sentences we infer the new sentence. Look at here. Here King John, greedy John implies evil John. That means these sentences is inferred from our old sentence, that is for all x, king x and greedy x implies evil x. Here in place of x we replace, that is John. That means in our knowledge base sentence we replace the x variable by John. After replacing x by John, then we get a new sentence, that is King John and greedy John implies evil John. In the similar manner, we can derive another sentence, that is King Richard and greedy Richard implies evil Richard. Here the x variable is replaced by the Richard. Then next one is the King John, greedy John, then brother Richard John. That means these are the sentences which are derived from our old sentences. Now the new knowledge base is propositionalized and the propositional symbols are King John, greedy John, evil John, King Richard and others. That means when we use the universal instantiation or existential instantiation in our knowledge base sentence, then from the old knowledge base sentence we derive the new sentences. After deriving the new sentences, then we identify the propositional symbol. Here the propositional symbols are King John, Greedy John, Evil John and King Richard. Next, unification. Unification is a process of making two different logical atomic expressions identical by finding a substitution. That means in unification we make two logical atomic sentences identical by substitution. Here unification mainly depends upon the substitution process. Next, it takes two literals as input and make them identical using substitution. That means in unification it always takes two literals as input. Then by using the substitution it makes these two literals identical. Here we can get the inference immediately if we can find a substitution theta such that King X and Greedy X matches King John and Greedy John. That means here the substitution theta, that is the X variable is replaced by John and the Y variable also replaced by John. When we substitute these variables, after that we apply the unification, that is unify AB equal to theta if A theta equal to B theta. Here in unification the important thing is substitution. That means when we get a substitution between two different literals, then we make these two different literals identical by using the substitution. Now look at the example. Here P and Q are two different literals and the first value of P is knows John X, then the Q value is knows John Z. Now look at these two literals, that P and Q. Here in P and Q we can replace the X variable by Z. That means in place of X we substitute the value Z. When we substitute the value Z, then P and Q are identical. That means here we can say that the unification uses the substitution makes P and Q identical. And here the substitution value is, that is X substituted by Z. Now look at the second one. In second one the P value is knows John X and Q value is knows Y O J. Now here P uses a variable X and Q uses another variable, that is Y. Here if we want to use the substitution, that means in this case the X variable is substituted by OJ and the Y variable is substituted by John. When we use this substitution, then the P and Q becomes identical. Now look at the third one. In third one, that is knows John X and Q value is knows Y mother Y. Here in place of X we can substitute mother Y and in place of Y we can substitute John. When we apply this substitution, then the P and Q both are becomes identical. That means here the unification satisfies and makes P and Q identical by using the substitution. Now look at the last one. In last one the P value is knows John X and Q value is knows X OJ. Look at these two values. In case of P the variable is X and in case of Q the variable also X. That means here P and Q both are used the same variable, that is X. That means here if you replace this X variable by OJ, then the X variable of Q must be replaced by the value, that is John. Here the same variable X cannot contain different value at the same timing. That means in this case the unification fails. And here the unification fails only because of the same variable used in two different literals. If we replace or rename one of the variable, that means suppose the P literal is knows John X and the Q literal is knows Y OJ. That means here This is same our second case. That means if in Q literal we use the variable y, then we can apply the substitution, and the substitution is x is replaced by OJ and y is replaced by John. After that P and Q becomes identical. Here in unification, you must remember that unification always uses the substitution to make two different atomic sentence identical. That is the main function of our unification. And in unification, if same variable is used in our two different literals, then these two different literals or two different atomic sentence cannot be identical, because in this case we cannot use the substitution. This is all about the unification. Next, generalized modus ponens. This is a general inference rule for first order logic that does not require instantiation. Now look at the formula of modus ponens, that is P1 dash P2 dash up to P1 Pn dash comma P1 and P2 and up to Pn implies Q, that is replaced by or substituted by Q, which means here P1 P2 Pn dash, and that means here P1 dash P2 dash up to Pn dash comma P1 and P2 up to Pn, that implies Q, which means substitute theta Pi dash is equal to substitute theta Pi. From this we can conclude that substitute theta Q. That means here in place of P1 dash P2 dash up to Pn dash and P1 comma P2 up to Pn, we can replace Q. This is the modus ponens rule. Now take one example of this general modus ponens. Here in this example, for all x parent xy and parent yz implies grandparent xz. That means here parent xy means y is the parent of x and parent yz means z is the parent of y, which implies grandparent xz. That means here z is the grandparent of x and here x, y, z are the variables. Now from this we can derive the new sentence by replacing these variables. Suppose the sentences are parent James John, parent James Richard, parent Harry James. Now using these we can derive grandparent Harry John, which binds X Harry, Y James and Z John. The next one is grandparent Harry Richard. Here this binds X Harry, Y James and Z Richard. This is all about the modus ponens, and this modus ponens is used in our first order logic. This is all about the inference in first order logic. In inference in first order logic, most important thing is that is universal instantiation and existential instantiation. And here in universal instantiation, you have to remember that instantiation can be used more than one times in your knowledge base to add the new sentence. But the existential instantiation can be applied only once to our knowledge base. If you have any doubt regarding the inference in first order logic, then you can write me in comment. I will reply you and discuss about your doubt. Thank you for watching.